there's something that I cannot live without, it's observability. If there's no observability, I cannot operate any of the systems I engineer.
So suddenly you go into this growth phase where you're scaling everything, and what happens is there's burnout in your engineers.
Sometimes when we are scaling the services and data, we don't think about the long tail processes that are adding up into queue and taking longer.
Hello, everyone, and welcome to another episode of Our Tech Chronicles. This is episode 11. We're double digits now. Pretty cool. Today's topic is the science and art of scaling your SaaS. We're going to talk about when should you scale, technical challenges and solutions. We'll explore some scaling pitfalls and how to avoid them, and we'll end with some real world examples. Today, we have a treat for you. We have a special guest. We have Taranga here who's going to join the discussion. Taranga, you want to introduce yourself quickly to everyone?
Yeah, hello. Hello, everyone. My name is Taranga. I'm a software engineer. Thanks for having me.
We're really happy to have you. Taranga is being very humble. He comes with a really solid background in with databases, worked at Netflix, Google, and now he's at LinkedIn. So we're very honored to have you. Thank you for making time for us. All right, as always, before we get started, if you had to describe the process of scaling a SaaS business in just one word, what would it be and why? Go. I'll go first then. Roller coaster.
It's a good problem to have. If you're at a stage where you need to scale your startup, that's a really, really good problem to have.
Yeah, I agree. You're in a good place, right?
You're in a really good place, yes.
I would say elasticity.
Okay. Yeah. Cool. All right, let's get started. If I was a founder, when do I determine the exact point that I need to start thinking about scaling my SaaS?
In my experience, I mean, a lot of people don't do this, but I think there should be some preliminary analysis that should be done even at the ideation. When we are talking about a problem and how we want a solution, we need to think about financial viability first, right? Probably in a startup environment, we don't need to do that, but in a larger enterprise, in order to secure funding, you need to show profitability. So some level of analysis that needs to be done to kind of estimate the running cost and the growth potential and sometimes even royalty, because we may have to pay someone else for every service offered. So I think at the forefront we need to do preliminary analysis, and after that needs to be a continuous analysis that needs to happen.
Cool. Maybe I can add to that. For me, like this, sometimes the indicators are pretty obvious, right? Assume you have figured out product market fit, and you have so many customers wanting to use your product, and they're experiencing degradation in the service, maybe in customer support. It comes in different ways, right? In your NPS score, things like that. Those are like indicators that, hey, you're probably behind. You need to scale now to support this new demand that you're having. What else?
So for me, compared to a large organization, the startup, the founders are quite involved and quite closer to the business. And when there's a problem, everybody knows it because your customer service sits two chairs next to the software development, right? And the sales, because it's pretty much one group. And the prioritization of issues are much better compared to enterprise. In enterprise, you probably need to do a survey to understand what are the custom issues. Whereas in a startup, founder's phone gets ring when there's a problem, right? So it's very close loop. In my opinion, most of the startups issues are very visible and everybody knows everything. It's just that money, time, and also how to do what to do, knowledge is what's missing. Most of the startups, they know their issues really upfront, and when you speak to those founders, their prioritization is really good, but it's just that the knowledge sometimes or the funding sometimes is what's lacking. So I think we will go down the path of the knowledge sharing that knowledge so that they know what to do, how to do, and how to lower the cost and things like that.
That makes sense.
How about the business side? Like when you're a startup and when you're on the trajectory of the growing, sometimes your business side could get stagnant. Your business side is not growing, or your business side is growing and your engineering side cannot keep up with that. So I think both are two different points of think about, like when to scale.
Exactly. That's very true. Very true.
I think I didn't do just explaining earlier about why the initial analysis is required is that oftentimes startup are very excited in solving a problem, but if they didn't do the competitive analysis or market analysis of a similar service, how much it is going for, it'll be too late when they build it to see we are incurring more cost, right, for the same services that are out there already. So then they'll get into scaling, and sometimes it gets very costly to do the re-architecture at that point. So sometimes we have to make a hard call at the beginning saying, with the available skill set of the team and basically using some of the tech stack that we were hoping to use, it may not make sense to go to market at a certain price point.
That actually is a nice segue into our next section, which is the fun part, right? Technical challenges and solutions. So, what advice and things would you share with startups, with small, medium size enterprises, perhaps, right? When they want to think about scaling.
So one very common problem that I've seen is the slow database. That's something most of the startups run into. A slow database could gives you a very bad customer experience eventually, because your front end is through some mechanism is eventually connected to your DB. The latency of or the delay in which the data can be retrieved or write back uh, gets propagated all the way to the customer experience. So when it happens, usually it happens uh, for multiple reasons. So one of the reasons is we kind of normalize the database and we kind of optimize the data storage for write performance. You remove the duplication, you normalize data, which is really good structure for writing data and maintaining. But in reality, you write once or twice, write once or then modify a couple of times. Rest of it, it's all read. So what we call these databases are not read optimized, and they are optimized for writing, which is probably couple of percentages of the real usage. Rest of it is all read. So now you are in a situation you write real fast, but you keep reading and you're reading, but the performance is slow. What can you do in a situation like this? Most often I have figured they use their just one database to write as well as read. What makes sense is to have a read replica and a somewhat read optimized data store so that most of the reads can go to that read replica and read it from that so that you are not taxing the main master DB. That's a very simple setup. Any cloud database provider can give you that, or even something, if it's your on-prem solution, you can set it up. You have your master database for all the writes and spin off multiple read replicas, and read replicas most of the time works on your binary log so that it's not really taxing the master database, right? It keeps replicating through the binary log. Binary log is the only data source that it used to create the replication. So I think that could solve most of slow database problems, like if you're at a very early stage and if your database is slow.
There's a pattern for that also, no? CQRS. But just to add to that, also for database, I mean, there's so many patterns out there that you can lean on. So that is one that you explain. But other things is probably sharding, right? Depending on your load. I mean, I'm not only thinking small startups, but I'm thinking like big, fairly big companies, right? Um, Obviously, replication. Depending on the type of database you decide. Sometimes you have multiple different databases for different types of problems, right? So it's up to you to leverage the right type of data store.
Yeah, I think it's very important to figure out what kind of a workload that we have on the database, the read-write ratio, the nature of the workload, and based on that, what kind of a data model that we can have that touches that whether we have a read-heavy workload, write-heavy workload, or whether we can use a different kind of a database altogether. Another pattern that I've seen that in very useful for the read-heavy workload, to Anjana's point, is to have caching system
Mm,
because think about the read write workload and think about the staleness of the reads that can be survived for this particular scenario. Not all the scenarios the workloads are read heavy. Sometimes it's write heavy, sometimes it's split 50-50, sometimes it's read heavy. So if the workload is read heavy, having a good caching system, a distributed caching of some systems are a good way of scaling a read heavy workload.
I love it. What about the architecture itself of your
Yes.
system?
Yes, and the other point that Roshan mentioned about is the type of the database that we should have. Sometimes the read throughput itself is humongous, and the traditional databases or the traditional relational databases would not scale for this. So another type of a database, a key value store, or
Mm.
something very specific that can hold such a large throughput, uh, maybe a good fit, but always understanding what is required, what is the trade-off, whether that trade-off works for the business scenario that we are going to build the system is very crucial.
Very good points. Yeah, that's awesome.
Achieving 100% scalable is myth, right? I mean, it's impossible to have fully scalable application unless it is a minute service that we are providing, right? So it depends on where do we need to scale, where do we need to focus more, and I think the user behavioral analysis is very important when it comes to scaling. So one part that I can mention about the data side is sometimes you observe that the users are mostly requiring recent data. So it's okay to wait a little longer for old data. So then you have hot, cold, warm data separation there as well.
Yeah, it's cool.
As to on the same lines is getting your house cleaning practices right. Delete data which is not required from your database, right? Because not everything is required in your transactional database, and that the connecting to what Sean said. So understanding the transactional data and analytical data, and at what stage transactions become analytical, and having separating those two concerns, having one data store for analytical, and in the analytical, it's always aggregated type of data. Right? You don't need all the details. So having that division of data and understanding when to move is also a very important thing. And it's once you build that, your transactional database become more relevant and size optimized.
So we talked a lot about databases. What about services? What should we do? Okay, I can go first. So again, it depends on your workload, and it's better that if your services are decoupled and you have microservices or whatever you want to call it, but individual components that can scale independently based on their workloads, so that you're not trying to scale a giant monolith. You're just scaling individual components based on the demand, right? So that's where the elasticity comes into the picture, right? Another key aspect also about this is you have to really think twice about the communication patterns between your services. Everything doesn't have to be synchronous, like API driven. Think about which ones can be asynchronous. Use queues to your benefit so they can run workloads separately without taxing everything else. I could go on actually, but what else? What would you add?
I'll add something. So there are these languages, compiled languages versus interpreted languages, right? Something I realized in the startup in the scaling world, when you have a interpreted type of script type of languages, and when you have written things like PHP or any script, the way it works, when the request comes, that particular script get loaded to memory and it runs. After that, it's completely cleared off from your RAM. It's like almost like a microservice that gets spin off, does its job, and dies. right? And it doesn't sort of consume any memory after that point. Whereas in a compiled application that's already loaded into the RAM, whether you use it or not, there's a minimum RAM footprint and keeping that for a while, right? So it's again how you optimize it. But for what I've seen for most early stage startups, having script based, interpreter based languages reduces their footprint, and
Mhm.
also they can measure what's their peak hours and maybe scale computing only for those peak hours. So there's slight advantage for them using interpreter based languages because it only consumes when it's get loaded and executed. That's something that has worked for them. So that's also something to write your services if you are an early stage startup.
Another pattern that we can follow is to make the services stateless as much as possible. Uh, like get rid of any state. Even some obvious state is data that we stored in database, but beyond that, some of the services like to keep state of the request, and they eventually become kind of stateful and have to go with sticky sessions and everything. So trying to make the services stateless to the greatest extent is also help to scale the services.
Very good point. Yeah. Another one I would add is now with cloud native platforms, right? Use all of these things to your benefit, right? Manage databases, serverless, depending on your workload. Again, it depends on your workload, but there are so many things at your disposal that you can use to scale for free sometimes, obviously with a cost, but without engineering overload.
Yeah, another one to add is be aware of the limits put in external services, because the chances are that you probably need external services that you have no control of, like geocoding services or some other external third-party services. So we need to be very aware of the limits that they have so that we can manage the scaling side of things.
Switching gears a little bit. So, as you company, this is what I've observed, right? As a company goes through the process of now scaling and dealing with scale, this is where platform services are born, where you have dedicated teams building like API gateways, authentication, authorization services, right? To handle all of these at scale, to do your event bus, for example. So this is where you have to pay attention of building these building blocks. I think of it like Lego pieces that other services just consume and get the benefit out of for free. And these platform teams, their main concern is building solid, scalable, generic components. Right? Would you agree?
That's definitely something we'll discuss a little bit detail also in the team structure when you're facing scaling issues. How do you structure your team? That's definitely a good point. How dividing between your what we call the hub and the spoke. Hub is the platform team, and then you have a spoke teams for building on top of the platform and creating features and stuff like that. So that type of team structures we can talk about in the scaling with the team, or this how to structure the team for scaling.
When you build such platform services, their reliability become very important because many services and many other application parts are relying on them. So not only for the scale, but design for the reliability, especially for those platform components, are like super important. And for reliability, we can follow patterns like redundancy, which is very commonly used for both services and data to make them reliable.
What about observability?
If there's something that I cannot live without, like it's observability. If there's no observability, I cannot operate any of the systems I engineer. So observability is like the day zero requirement.
I like that quote actually. That's a very good quote.
Also, it's very very common without this saying called you can't control what you can't measure. So you should be able to measure it. Then only you can control it. You can steer it. So if you are one of the tech leaders who want to steer this, you need a lot of eyes, and that is what exactly the observability gives you, or visibility into the operations, into your technology, into your infrastructure. Without that, You're not a leader who's in control. Otherwise, you become very reactive, right? When something goes wrong, you only look at the log file at that point of time and you fix it. There's no preventive operation when you don't have that visibility. And observability gives you that.
As a leader, I love dashboards. I keep quoting that I can't drive a car without a dashboard, right? Until it is fully autonomous, we are not there yet.
That's very true. Very
Yeah.
true. There are two more things I want to talk about a little as well. One is security at scale. So as you start scaling out security, you should not ever forget about security, right? What should teams do with regard to secure practices they should do?
I would say like we need to protect the SaaS solution for like the DDoS, someone maliciously calling your services repeatedly that actually puts a lot of strain and break your system. And another one is spike arrest for protecting APIs. So I think these are important measures to put in to also protect financial implications from these.
So my areas of that is security as a domain is complicated, right? And it's ever changing, and we don't know this as there's nothing called 100% secure. There is some way of getting around, right? But if you bring in practices which is more business driven, and for instance, start with who should have access to information.
Hmm.
That's a very common business problem that you can solve. Who should have access, and when do people need to access, and when do you revoke that access? Bring those business thinking into your product, and then it's very easy to translate those into some technical requirements and technical implementation. Most of the businesses don't have that, especially when you're a startup. Everyone has admin access, and then what happens is someone sort of leave the organization, they still have access to that GitHub repo or whatever. So think in terms of business. Who should have access? When they should have access? Why they have access? And when to revoke access. Start with those simple stuff from a business requirement point of view. Then translate that into implementation. And who should have access goes to internal employees, external customers, systems, and that becomes sort of you start thinking in security for that matter.
I'll actually extend that not only for to people but to services as well. Same questions, right? What data should the service have access to? And you follow the same questions, and you'll secure your distributed system now as well.
Beyond the basic the security measures that we are aware of, protect data in transit, protect data in rest, it may be a good idea, like especially if you're dealing with sensitive data, it may be a good idea to bring a specialist on board as a consultant to make sure that you're following the best practices, especially if you're handling like financial data, for example, to have that jump start to have a domain expert's advice on how to do the things right, because this is a very critical area which could bring your SaaS down overnight.
Taranga, that's like, I think you hit the nail on the head there. One of the experience that I've had is we had to separate out like regulated, unregulated, entire path for data, and that required huge re-engineering after the fact. So it is important to bring them earlier on and then have that compliance reviewed before we go live. Yeah, good point.
Just to add on the security also, I think it's tangential, is as you scale, now you have to have a more robust hot and PIR process as well, right? Incident response. So these are things are like processes that get born out of scaling. You want to mitigate your customer impact as fast as you can, but then you want to also want to plug those gaps so that it doesn't happen next time. The last thing I wanted to talk, actually, I have two actually, but one more thing I want to talk about is vendor and tooling choices, right? Does that play a part in scaling, like build versus buy?
When you want to initially start SaaS offering or a startup, you tend to rely on the managed services, and managed services give you a boost, like they help you to get the scale that you want very fast. But over time, when you are when your business grows, you always have to evaluate whether the managed service can scale with your business. A database is a very good example. You may start with a simple database without thinking too much about the scale. And as you scale, whether the full data set would fit into a single node, a simple database. And if not, if it's not the case, then it is time to think about a better solution. Now, the hard part of the databases are, unlike services, scaling databases are pretty hard. So it is always to understand where the scaling trajectory is and to plan ahead, so you're not holding your business hostage because you have a small database that cannot scale.
Just to add to that, when we are thinking about vendors, we need to look at the pricing model they have and whether it is congruent with your plans for monetization. Do they have a generous offering for startup so we can scale for as long as we can and then start go into paying model? Another one is how reliable these vendors are, because your entire system is now dependent on this, right? So we may have to implement like cascade logic if you can find multiple vendors just to safeguard your SaaS solution as well.
Just to add to that also, I think especially if this is not your core domain and you want to plug a gap. For example, Sean, you mentioned DDoS protection, right? You don't want to build that stuff. There are so many providers out there that you can just leverage. Obviously, do the cost analysis, pick one of those, right? I think that's a fairly straightforward example of just deciding when you want to buy. The last piece I want to talk about this particular topic is the last mile, which is actually your front end performance. You might have the greatest scaling back end, the best database, but if your front end sucks, that's what your users use, right? And so if you don't use like CDNs and best practices on around front end, I'm not a front end guy, but you lose the plot again. So it's like end to end. You have to think of scaling from your front end all the way to your data store. And so that also goes with mobile. The mobile experience also has to be pretty performant. Would you agree?
On the front end, one of the very first things, performance is perception, right? It's how you perceive. The UX plays a big role. The way the user experience is architected in that, how the data is presented, how the buttons and the workflow is presented, which users can have a very good perception about the performance if the UX is right. Even though you have highly performant backend systems, if the UX is not right, still it's seen as a slow, not easy to work with system. So getting that UX right is very important. And most of the stuff, needless to say, the 80% of their success is their UX, right? And then rest is actually support in IT supports rest of the operations, but it's predominantly UX. So you need to get that UX part of it. Part and parcel of the UX is how you engineer your front end, the UI engineering part of it. So when it comes to that, bring in the right type of frameworks, bring in the right type of technologies. Like for some instance, if you need real-time information, having that pops up being implemented in your browser level without without having the need of refreshing the browser all the time. Simple things like that actually adds a lot of value.
One of the things that you mentioned in the beginning about the performance of the backend is also part of like basic user experience. Having a very low latency makes the system seamless.
Before we move to scaling pitfalls and how to avoid them, is anything we may have missed?
One thing I think Sean mentioned about is the cost of scaling. What is the pricing model of your SaaS and how it boils down into the cost of the infrastructure, especially if you are on cloud. I think to be conscious about that is very important to either slow down the burning of your VC money or to increase your profit. Have to have a very good relationship between pricing and the cost of the compute infra is very important to scale your SaaS.
Yes, so that's something model most of the startups can follow is to think of the unit P&L. What that means is if you have a couple of LOBs in your startup, you can have the cost, profit and loss per that unit. Let's say you have a retail element in your startup as well as a corporate element. Sometimes Most of your computing is on the retail. Actual money comes from corporate or vice versa. Get that visibility. Understand the unit level P&L and L and the profitability, and always break it down based on by some means a usage, or somehow get a clear understanding of your infrastructure bill, the money that you spend, connect them back to the service that you offer, and have that visibility. Then that gives you a very clear prioritization whether you should increase the price, change the services because you're spending too much money on the back end, or it's a situation where you need to talk to engineering and architecture teams and re-architect, re-engineer, because it's not a scenario where you can ask for more money, increase the price of the feature. Rather, you need to go back to whiteboard and change the change the system.
The monetization is something that is not thought through most of the startups, right, until latter part. So it's so key that Anjana's point about UX playing a huge part, especially when you're designing a freemium model. We have to be extremely careful. The free portion of the features that you're building is not going to be the most costliest thing that is going to, eat up your budget. So, and I have some nightmare stories I can talk about later. But yeah, so we need to be very careful to not front load heavy transactional nature of processing in a freemium model.
As always, if you guys like content like this, don't forget to hit subscribe. All right, let's quickly talk about some of these common pitfalls and how to avoid them before we get into such a fun real world stories. Maybe I'll go first. The thing that I've seen a lot talking to, young companies is premature scaling, where they have hired people from maybe big companies and they bring in that big company thinking and they deploy in multiple regions. They've set up all these scaling practices, but they don't have enough usage, right? And so your expenses are not proportionate to your revenue growth. That's a sign that you've prematurely over optimized your architecture. I've seen that a few times. Don't do that. Right? What else?
I think the other one is the build versus buy. Now we call it build versus operate, right? Have that trade-off analysis. And certain services, when you build it and when you operate it, it's way too expensive. And at an early stage or for a scale up, they can always use them on demand as long as you have build it, build those connected to those services via proper interfaces where you can keep switching those. You're all right. So build versus operate is a good decision, and you have to really invest time on that and make sure that you keep the cost really low.
And maybe another one is what I've seen is, you know, especially in a small company. So suddenly you go into this growth phase where you're scaling everything. And what happens is there's burnout in engineers. They're like working round the clock to keep this thing running. So there's a culture erosion, people leave, right? So be careful of that. You need to set up good practices in place so still a good balance so that people still can operate your systems.
The other end of that problem is overhiring.
Yeah, that's another one. Exactly.
Yes. And not just engineers, right? We have to think about, like, to Taranga's earlier point, it's the whole business staffing, because even if the software is able to scale, the people who are supposed to help with other business processes like picking up support calls or doing administrative stuff, if they are not timely attending to those tasks, then it's the customer experience is going to suffer.
Another one I've seen, if you try to scale really fast and not in a thoughtful manner, is sometimes you end up with these over complicated processes in place. And just doing a simple change and upgrade becomes so complicated. So this is why when you scale also it has to be done very thoughtfully, not only about scaling, but the operational aspect as well.
Another angle is when you have to scale, most of the founders, something that comes to their mind is acquisition. Let's acquire a company that, right? It's actually good. I'm not against it, but get your engineering team involved in that decision, because you don't want to be in a situation you acquire something from a functional point of view, it's a good fit. But however, it's an engineering nightmare to integrate or to maintain. It could be a completely different technology stack. It could be really hard to integrate with it. So it's a good decision. It can go both ways, but get the engineering opinion before you acquire. Again, it's a really good way to scale fast. You acquire a team or a product which has solved that problem so that you don't have to go through the same issues that so you don't have to reinvent the wheel in that case. You're just getting that knowledge plus the product. So your maturity goes up overnight with that. But do that with a trade-off analysis.
Also, not build too much without a good market feedback, because we might have gone in a different tangent than actually what needed by the market. So getting that feedback early and frequently is very important.
Very true.
Sometimes when we are scaling the services and data, we don't think about the long tail processes that are adding up into queue and taking longer. So I'm talking about things like maybe there's ETLs or airflows going on, sometimes even notifications getting queued up. These could hurt customers as well. So keep an eye on those long tail processes as well.
And sometimes it is fine to make quick decisions because you want to move forward, but it's important to make that consciously and like be aware of the trade-off that I'm making.
Shall we move into some real world stories?
I can talk about some business related issues that I've faced. There was a time when one of my employers built a SaaS solution, and this goes back to my example earlier. The monetization strategy, they built the solution, and it was a freemium model, and they built it in such a way the free version users get to perform really complicated search, and then they get the result, but we catch them for monetization only after they select the results into getting analysis. So what we found out after months of launch is that over 99% of our users were just happy with the results. If you look at the user analytics, you can see the drop off point is right after search. And this costed us a lot of money because we were using BigQuery. I think monthly cost went up to like once $30,000. And then we were like, oh, this is too much to foot the bill for free users. We had to do something. So then we reanalyzed and then brought aggregate results instead of using transactional search. And then we also approximated the results so that they entice the user to go to the next one, which is actually the paid model. I thought that was a good example to start with.
Yeah, so I have one example where this was a startup. There was a senior tech guy. He's actually the CTO of the startup. I was more of a consultant to the startup, and then there's engineering team. Every time the CEO, the founders, and the product teams, when they come up with their own features, engineering teams estimates are challenged by the CTO. They say, hey, this estimate is like 1 month. I can do this in a weekend. This takes 10 days. I can do this over a weekend. And this is a type of argument that keeps going on for a while. And then there was a point they wanted some features. The team's estimate was like 5 days, like a week. He said, I can do this overnight. And so he said, okay, fine. If that's the case, because the individual was very confident of doing so, the founder made a decision, okay, we're going to skip the team. We're going to let the CTO, the most senior tech guy of the team, to build it and release it to production overnight. This guy actually worked overnight, built the feature was released. The next day morning, we were all got into a call, and the feature was built. The engineering team also looked at the feature. It's working, all good, went into production. And then everyone was start talking about, hey, there's a lot of stuff that we have to unlearn of how we build software, and we have to relearn. That's a process. A lot of positivity. What happens during the peak hour? System got crashed, and it took more than the whole evening for them to bring it back. The engineering lead couldn't actually recover the system. There were data loss issues. There were so much of other issues with it. and the team had to involve and recover it, roll back some of the stuff. Uh, I think the moral of the story is important. It's both ways. Your traditional way of doing things, maybe it takes time. There's definite opportunity for you to change it with new processes, new tools, new techniques. But also the other part is the risk that you take by skipping some of the traditional steps. Things like unit testing, things like functional testing, things like pilot, right? When you skip all of that, there's repercussions as well. It's not. So you have to strike a good balance between supporting business continuity plus speeding up things. So that was actually my lessons. Because it's also a positive thing. In that team, their productivity went up after that point because he proved a point. He built something 5 days of estimate in overnight, right? But also, I think that engineering lead, he also learned a lesson. There are certain things, checks and balances are there to protect you from things like this.
Hmm.
Uh, for me, it's a very good learning from that.
It's a good example. I like that one.
I have an example that so at Netflix, one of the key metric that is being measured is streams per second. It's like how many streams that are started in a given time, and our goal is to maximize that so that users watch on Netflix more and more. And then on the other hand, one of the goal is to minimize the cost of a stream by the infrastructure. As the streams are heavily using the caching infra, over time, as the business was growing and scaling, the amount of the data that's stored in the caches grew, and they were becoming so expensive. So one of the decisions that our team had made is to re-engineer some of these caches to use SSD instead of the DRAM to store large data sets. So by doing so, they were able to slash that growth and they were able to like bring down the cost per stream, which means now business can go and work on different business models to have more streams per second and have more subscribers with the same cost. So having some really good technical innovations to bring down the cost per unit is helpful to scale the systems.
That's another nice one. I like that. Cool. Shall we wrap up on that?
Sounds good. So we talked about when you should scale and some of the technical challenges and solutions, both data and services side. We also walked into some of the pitfalls that are common and then finally ended with some real life examples. We will see you in our next episode.